Allow me to introduce to you the theory of quantification. More specifically, it is gravitational neutrino dividend. In the beginning, an infinite life particle, the photon, gains infinite position. This is quantum space, not the fabric of space that we know, general space, quantified space-time. No, it's quantum space, where infinite position first arises, and where the unlimited potential, that is quantum force, first comes to be. In order for the photon to truly gain infinite position, it must create superposition with the power of quantum force, which infinite position and superposition comes from. The neutrino at this time has nothing to fall into besides the ghost neutrino, which it is that the ghost neutrino is the father of the neutrino. At this time, the anti-exciton neutrino, with this gaining of infinite position and the beginning of quantification, is racing away from itself, the non-neutrino counterpart of itself, the anti-exciton. From there, what we have is that neutrino creating something called the AntiGraviton, which becomes trapped within the light of the anti-exciton neutrino. The neutrino is the godfather of the AntiGraviton. And so, when it becomes trapped, and the anti-exciton is trying to catch up with itself, the anti-exciton neutrino, more gravitons, anti-gravitons, are coming to be within here. And that is because the anti-exciton is falling directly into the light of quantum force. And this is creating something called the exciton. And so, because the anti-exciton is falling directly into the light of quantum force, more gravitons, anti-gravitons, are coming to be within there, as these ones stay trapped and eventually die. It means the same for those new coming anti-gravitons. And so, more excitons are coming to be. And as this process continues to happen, it's just going to mean more and more and more excitons. Until eventually, so many excitons have come to be that it builds the exciton neutrino. And thus, the anti-exciton neutrino and the anti-exciton reconnect. And this forms the mother white hole of quantum space. That is what occurs. And so now, the neutrino can fall into the force of the exciton neutrino. And many things can happen. Because when the neutrino can now fall into the force of the exciton neutrino, the exciton will fall directly into the light of quantum force, depending upon what the antigraviton will do within the light of the ghost neutrino, because it is being pushed out now. And yes, it's pushed out. It is either trapped within the light of the ghost neutrino, or it will die, depending on what the exciton and the neutrino does. Because now, what happens within here is not the antigraviton. Now, normal gravitons come to be, and the antigraviton is the father of the graviton. The neutrino is the godfather of the graviton, both antigraviton and graviton. And the ghost neutrino is the father of the neutrino, as stated before. So, where I left off, the exciton neutrino of our mother white hole has been built. And this means that the fabric of space, the spatial void, quantified spacetime, is now present. And this will eventually mean that black holes come to be, and that we will have a universe within our parent universe, our greater universe, the mother white hole. What happens within here is graviton release, while what happens right here, where the exciton neutrino and the anti-exciton neutrino connect, is graviton death. That's the only place that it happens. Graviton death only happens right there, not within. And that is part of quantification, as it were. That is how it works. And right here is the antigraviton, and it will either die within the light of the ghost neutrino, or it will stay trapped. Both are happening at the same time, and because of that, many things can happen between the neutrino and the exciton. Not the exciton neutrino. The exciton is within the exciton neutrino, as it were with the anti-exciton and the anti-exciton neutrino. So, when the antigraviton is trapped within the light of the ghost neutrino, and the neutrino is falling within the force of the exciton neutrino, and then the exciton is falling directly into the light of quantum force, what comes to be is that particle that we all know. It's called the electron, that elementary particle that holds the atom together. That's what's happening when those things align. Now, another thing that can happen when the exciton is falling directly into the light of quantum force, the neutrino is falling into the light of the ghost neutrino, the force of the ghost neutrino, and the antigraviton, in this instance, is trapped within the light of the ghost neutrino. What comes to be is the anti-exciton. Yet again, and this particle is what allows for superposition. The exciton, you could say that it is the particle, the counterpart particle to the anti-exciton, that is electromagnetic and enables quantum tunneling. That's what this little guy does. And it does not exist in quantum space. It's only within general space. Now, while all of that is occurring, this time, in this instance, if the AntiGraviton, which it will happen and is always happening, as well as these two, they are always happening. It's actually dying within the light of the Ghost Neutrino this time, the AntiGraviton. The Neutrino is falling within the force of the exciton neutrino. The exciton it might not exactly be falling into the light of quantum force this time, but what comes about is the graviton, right here. And this is not graviton death. What's happening from the beginning to the very end within our universe is quantification. It's gravitational neutrino dividend. Immediately, something called quantum fusion begins. And all matter will eventually lead to black holes, which I would dub quantified matter, the main component matter to quantum force. As is the mother white hole. Eventually, black holes and our mother universe will form a bond and begin the process of quantum fusion. In the beginning of a black hole's life and the universe, you could say that quantified matter, dark energy, a black hole, uses the weak nuclear force to expand and create more matter. But eventually, it will carry the strong nuclear force and form this quantum tie with our mother universe. And everything will eventually harden and lead to graviton death and expel and quantify. You could say that those gravitons that are dying will eventually lead to them becoming anti-gravitons and partaking anti-graviton death. Is presumably so. This is all happening simultaneously. And our mother white hole should be enacting that quantum fusion aspect on itself in the beginning with its own exciton neutrino. A black hole would be exciton neutrino dominant, whereas our mother white hole is anti-exciton neutrino dominant. The black hole is dark energy dominant, whereas the mother white hole, all throughout quantum space, it is ghost energy dominant. They are 2 parts quantum force given by the beginning of quantification and infinite position and the photon. As I stated earlier, this is gravitational neutrino dividend. And yes, the exciton neutrino is the essence of where ghost energy would dwell, other than quantum force, where everything should begin, and where infinite position and superposition is ultimately tied. Whereas the exciton neutrino, which only happens here in this fabric of space, is the essence of dark energy. So yes, only within here is graviton release, and where molecular matter comes to be and will go on to become black holes and will gain size or live their diverse life. But it eventually will always lead to quantum fusion and quantification. So in the next cut, I'm going to go over this molecular matter coming to be and what I think should be quantum fission, and how 2 black holes fuse together, and why they would do such a thing, because they need to gain mass and go on to quantum fuse. Quantumly fuse and go on to lead to graviton death and quantification. And when this graviton death happens, it also means that the electron will die with it. That neutron neutrino will be the last thing to quantify. It must survive and become a ghost neutrino again when the AntiGraviton is actually falling and dying within the light of the ghost neutrino. Every neutrino, in essence, is a ghost neutrino, even the electron neutrino. By the means of gravitational neutrino dividend, and what quantification means, that should be the case. Yep. So, as to the explanation of molecular matter and the coming of fusion, we start out with those excitons. Now, what should happen first is that exciton becomes an anti-exciton. There are still excitons all around there. Some more excitons should become anti-excitons. And eventually, these anti-excitons should cause a split between that anti-exciton and the electron neutrino. And when this happens, there does occur superposition. Now, those excitons should become gravitons. As to what was previously stated about what the neutron neutrino does and the exciton. What is all around still is the neutron neutrino. When all of this is happening, as the father graviton, it reestablishes a stability for the escalation of fusion. And so, too many excitons do not dwell, and the molecular matter just dissipate. That won't happen with the neutron neutrino. And all around that is the Ghost Neutrino, as it is the father of the neutron neutrino. Now, what these gravitons are doing, as more gravitons come to be, is way out here where En and AEN connect and where graviton death occurs. These gravitons are growing and developing, and they themselves are becoming neutron neutrinos that can act still as gravitons. And this is from molecular matter to a star. What this does not want to happen, here, is too many gravitons come to be at one time. If too many gravitons come to be at one time, they could respark the connection between the exciton neutrino and the anti-exciton. And then there it goes. There's a supernova. If it's at that stage where the star has become neutronic. Otherwise, it might just dissipate back into a black star. Might return to a rock-like state. If it's not neutronic in nature. So, what needs to happen is from the star's nearest point within, all the way without, where it goes all the way back to before the superposition, where there is no superposition out of the reaches of the star. Those gravitons must become neutron neutrinos at a steady pace where they connect, and then the star should, by healthy standards, become a black hole. And that black hole is itself a neutron neutrino. It's made up of neutron neutrinos. It is an exciton dominant force of nature. It also carries the anti-exciton neutrino. And what I said previously about our mother white hole, it is anti-exciton neutrino dominant, and we are within its exciton neutrino. the fabric of space. Now, what might be going on within a star, within its neutron state, is the development of quantified matter, a black hole. So, somewhere in its fusion, within this graviton makeup, it's creating something called quark-onium. And that quark-onium is likely developing into quark-gluon plasma. And then from there, quantified matter. So, if it got to this point, and for some reason too many gravitons built up, and it faced graviton release prematurely, and it went supernova, what might be left is a neutron star with quantified matter within. What might need to happen if, well, first of all, a star should have ferromagnetic gravity. That is what a star has. From point A to point B, from the star to the end of its gravity, should be ferromagnetic gravity. And within it, anti-ferromagnetic gravity around bodies, celestial bodies, and around celestial bodies, something called ultramagnetic gravity. When that supernova occurs, that quark-gluon plasma should want to circle around the celestial bodies, go without the ultramagnetic gravity, all the way to the end of the star's gravity, and try to melt that quark-onium, bounce back and forth, so that it can release that quantified matter and become a black hole. As we see with neutron stars when they try to feed on other stars, it's trying to melt that quark-onium shell. It's trying to get out. It wants to be a black hole. That's the destructive force that a neutron star is. And so, since a neutron star has quantified matter within, that means it has superior ferromagnetic gravity. And a black hole is superior ferromagnetic gravity. No star can beat it. A neutron star cannot beat a black hole outside of its quark-onium shell. Especially not one that came about of healthy standards, where it did not need to melt that. Did not fail in melting it. That is what a black hole is. That is how it comes to be. That is what it does. Now, it has a neutron neutrino of its own, which means it's made up of excitons. So it's, with this premise, an inside-out white hole. It might, to a degree, eat itself in combination with the weak nuclear force in order to create more matter around it. What it wants to do is create stars. It wants to allow them to turn into black holes, so those two black holes can join and perform something I would call quantum fission. That's what they want to do. So, I got some here kitty cat. So I will end this one here and get back to it. So, what this black hole is going through is graviton release. It is trying to create black holes, pull them together, and become larger. Now, this black hole has ghost energy. What might need to happen if a black hole's compression is so great is that some of those black holes it needs to flip the switch on and make anti-exciton neutrino dominant. And so they become ghost energy. And its superposition, the superposition of that black hole, expands. And so the black hole does not reach 0% dark energy and explode. This is what it might want to do naturally. What else might happen with these black holes is that when this graviton release is happening and this compression is happening, these supercharged particles that go into dark energy, they like to move out. And so within expands. And when it cannot do this any longer, and particles are shooting back and forth between event horizon and this opening within it, that opening within it, it's a quasar. Or a jet stream, early in its life, it's a little pulsar. It's a mini quasar. It releases matter. And it probably does this from the very beginning. And that's part of its matter creating. And when this occurs, just like the universe that we are within, what happens within is it's creating quantified space-time. It exists within the exciton neutrino of our mother white hole. These neutrino physics are happening all around us, all the time. And eventually, a black hole should grow so large that it finds itself in the middle of our universe. Maybe our black hole is one of those black holes. Maybe the great attractor in our universe is one of those black holes. And what happens with those black holes is that they begin to harden and carry the strong nuclear force. And ultimately, it reaches the bounds of where the exciton neutrino and the anti-exciton neutrino meet at the end of our universe, all the way to the mother whitehole. And that's where quantum fusion starts and ends. And this is where graviton death occurs. And this is where quantification is being fulfilled, all the way pouring out into quantum space. Rethink what you know about a white hole, because there are none here in quantified space-time. There's not a single one. That's a black hole. Flipped inside out. It's not a singularity at all. And it is perhaps that those neutron neutrinos that are acting as gravitons is what allows them to survive that graviton death happening here. So here is graviton death. Everything within is graviton release. It doesn't matter how much it might resemble quantum fusion here. Even if it's neutronic in nature, it has to be graviton release because of the neutron neutrino. So, when you put into perspective this, and you consider quantum space, here is a brand new mother white hole that has just formed in quantum space. Here is one that is undergoing quantum fusion. They could connect. That is reverse quantum fission. And this universe should grow larger. Quantum fusion should not be impeded upon. It should not have any complications. And when this happens, we could be talking about something like a great void opening up within quantified space-time. That could be the case. And so, what a white hole is anti-superior ferromagnetic gravity. Two mother white holes undergoing quantum fusion, they cannot perform reverse quantum fission. It's not possible. Two that aren't undergoing quantum fusion can. Two, well, one that is and one that is not, they can. And this, what I was saying about a black hole flipping the switch so that it might expand upon its superposition. That is a classical repair. That's not quantum fission like two black holes coming together. That is a classical repair. And this is how our universe is working. This is our universe. Not these scribbles, but this is our universe. And I have written it, and I have a document that you might read for a more in-depth particle analysis, if you wish. But perhaps this does shed some light on it. And if a Mother Universe were to undergo reverse quantum fission, the black holes are totally fine. Nothing would befall a black hole. But this new balance in exciton makeup could spell disaster for all stars that found itself in the pocket of this absorption. This is indeed it's gravitational neutrino dividend. It is the theory of quantification. That's what it means. So, not that a black hole is going through graviton death before the real graviton death when quantification comes about at the edge of the mother white hole. But it could mean that it has a great tie to the Ghost Neutrino. And so it's adhering by the same rules. Just flipped inside out. In terms of the neutrino, and what the exciton does when it falls into the light of quantum force directly. So, something else that I wanted to touch up on. I've probably covered the bases. I will continue if I have anything else that I need to expand upon. Okay, so if a star were neutronic and it had that too many gravitons basis where these gravitons were not becoming neutrinos and it went supernova, but it had not yet developed quantified matter within, it should become something like a white dwarf pulsar. And then that molecular matter all around would tenfold recreate this star. Create many more stars. Perhaps it's meant to do that. Perhaps that's what the universe wants to do. It is graviton release. A black hole goes through graviton release. Perhaps in some scenarios, it realizes that it will not be able to become a black hole, and it does that. And this field of superposition expands to such a degree, the AntiGraviton and it would reestablish that separation along with the help of the neutral neutrino within the weak nuclear force. And that whole process would start again within a whole greater field. Electron neutrino. AntiGraviton. Neutral neutrino. Perhaps it would. Perhaps that is what we are seeing. Indeed, we are seeing something of that nature, yes? And if I were to bet on it, I would say that this is the case. And a neutron star with quantified matter within does not need to rely on an outside superposition. It's 2 parts quantum force of that nature. When considering superposition becoming a part of infinite position and quantification, I would understand that it's 1 part exciton neutrino and another part anti-exciton neutrino, along with its neutral neutrino makeup. This is my understanding, and I hope you enjoy. When this relativistic jet happens early in a black hole's life, this should be a good indication that it's creating quantified spacetime within, by the means of gravitational neutrino dividend, the same quantified spacetime that we are within. A black hole may be within another black hole, within another white hole. This means graviton release for that young black hole. When a black hole goes through gravitational neutrino dividend, quasars can happen, and its compression is why. More specifically, it is graviton release, while it is also pulling matter in, and it means that it's burning dark energy. Quasars can also happen during special events, like 2 black hole galaxies undergoing quantum fission. During a fission event between 2 galaxy black holes, the black hole with a greater, superior ferromagnetic gravity always wins, even those that are not the father of a galaxy. The bigger mass black hole with greater amounts of dark energy and ghost energy would win. There is the probability that a black hole has to perform classical repairs in order for this compression from gravitational neutrino dividend and the subsequent quasar to not be too dangerous for itself and burn too much dark energy in the process of this fission. Though, if there are not any black holes that it has parented or absorbing that it can flip the switch on and turn into ghost energy in this special event, The black hole that wins this special event might have to destroy some of its inner quantified space-time and replace it with the dark energy it's consuming from the parent black hole of the other galaxy. So, that's this one, and another one. And if you... Yes, quasar. And if you read my theory that I've, written, and in my document, you might get some better illustrations out of this. Yes. I would feel remiss if I did not mention and did not remind that the exciton is an electromagnetic particle that would per se enable quantum tunneling, and that it is the non-neutrino counterpart of the exciton neutrino. And this exciton neutrino is the essence of dark energy within the superposition of our quantified space-time, given power by quantum force. That quantum force that is ultimately the greater of superposition, because it is the force of infinite position when that infinite life particle, the photon, gains infinite position. It is the electromagnetism that would oversee electromagnetism, in my opinion. The fundamental force, that is. And so, the anti-exciton would be an electromagnetic particle that is responsible for superposition. And it is the non-neutrino counterpart of the anti-exciton neutrino, which that one would be the essence of ghost energy, and in the same way tied to quantum force, as being a carrier of electromagnetism, and quantum force being that father of it. Both hugely important to quantification. Yes, as a matter of fact, I would say that infinite position gives rise to superposition. And that would entail quantification. And the means that it has to set up shop and work in what it creates, our quantified space-time, our general space, our fabric of space. Quantum force. A fundamental force. Again, to remind exactly what quantum fusion should mean for black holes and quantification and graviton death, I will demonstrate again. So this is the mother white hole, and right here is graviton death. Over here is the AntiGraviton, where it might die or stay trapped within the Ghost Neutrino. And these gravitons that are facing graviton death might eventually become anti-gravitons themselves, as everything is eventually pushed out, and where graviton death ensues. So, let's say there are many black holes within this hardening universe where graviton death is ensuing. It's ensuing. And so these black holes are using the weak nuclear force through gravitational neutrino dividend to expand and create matter and grow in size, undergo quantum fission, and eventually become great enough of parent black holes, and go on to form quantum ties with this graviton death. And they will harden. So let's say there's a great parent black hole that we are all within, or there could be many, considering the graviton death that immediately ensues from the beginning. But here's a ginormous one. And then within it are some more black holes that are not currently undergoing this ensuing graviton death and hardening with the carrying of this strong nuclear force. So this might be one, this might be one, this one, this one, this one. And so eventually it will. And you could look at these as great attractors. They eventually will. Everything will undergo graviton death at some point and harden. And dark energy will no longer burn. Ghost energy will only meet itself out here as it shrinks and shrinks and shrinks and shrinks and shrinks and comes to this fine point of a very hardened universe. Very small and has hardened. Perhaps that is what the great attractor is. Perhaps we are that far into quantification and graviton death. You could say that graviton death is necessary for the graviton release that goes on. This tie with gravitational neutrino dividend, and when black holes or stars undergo fusion. And when black holes use the weak nuclear force. But it will not always be so. And eventually this will happen. And until this very fine point, and then everything shrinks and comes to this very fine point, the neutral neutrino will be the last thing. And it will quantify as a ghost neutrino. Whether the one before it has to be acting as a graviton, that's what will happen. Or it itself has to be acting as a graviton. Graviton death must ensue. And everything meet its end. Right now, I would suppose that our universe has a very hard edge. And maybe we are within a black hole here that is very hardened, and there is another one right here that has hardened. Or another great one that has hardened. But this doesn't mean that per se our immediate parent father black hole has to be hardening. No. Doesn't mean that the great attractor has to be a black hole hardening. No. But eventually it will. And eventually it will carry the strong nuclear force. And dark energy will not burn. And ghost energy will meet its end with the anti-exciton neutrino. And everything will quantify. I would suppose this is what's going on. I do believe so. But there absolutely must be graviton death and the beginnings of quantification and the universe hardening. The inner part of the mother white hole is technically dark energy. So you could see how it does not need a black hole in the very beginning to start this process. My cat is in heat, that is, or the meowing if you hear it. But yes, I'm very proud of my theory. And I hope they are words of inspiration. Not only to the effects of your liking academia, but to the effects of rejoicing. It seems to me a promise, and that's why I'm so proud of it. And this is God's universe. And Jesus Christ is the death of ego. And you should not seek approval from any other man. Only the living God. And I hope you understand it. I spent years on it now. And I do believe it's a miracle of a theory. And gravitational neutrino dividend is a miracle of physics. Yes, that will conclude this, and maybe I'll think of more things. And this video is going to be an hour long, so take your time in watching it. Yes, at the very end, the very last thing should be a neutral neutrino. And this neutral neutrino must quantify as a ghost neutrino. If that means that the neutral neutrino before it has to be acting as a graviton, I believe that's what it would do. I would say that the last thing to quantify is a neutral neutrino. And this would be when the last of superposition becomes infinite position. And light has gained part of its infinite position. That is what I believe is occurring. And yes, I do hope that you've enjoyed it and that you enjoy the theory of quantification, more specifically gravitational neutrino dividend, because it must equals Q. That is G and D. That is talk. Theory of quantification. Yes.